Alright, welcome back. Of course, we're going to have a short little video on Chapter 7. Chapter 7 is kind of a big one. We go through quite a bit of content in Chapter 7. It starts out, as you see on this print here, but these prints here, there's 3 examples. We'll get to the other 2. They're showing you the different ways that prints can be dimensioned. What I mean by different dimensions, for example, you look at the example here on this page, figure 7.1. These are all in fractions. So it makes it very easy for you to read a tape measure. 3/8 of an inch, 2.5, 1.5. You also notice on this short little print here, this simple little print, you see that there's the diameter of these holes are 3/8 of an inch, and there's 4 holes. So all 4 of these holes are 3/8 of an inch. Also right here you see this half by 45 degree angle. That means it's a 1/2 inch this way, 1/2 inch that way, and it says typical. So what does that mean? That this one here is the same dimension as that one. When you see that word typical, that means everything else that looks the same is going to be the same as that dimension. You'll see that a lot on your welds. It might be 1/4 inch typical in the tail. You should know that already by your print reading class, and that means that everything on that print will follow whatever's on that reference line or leader. And that applies with other leader lines and extension lines also. So this example right here is showing you that it's using fractions of an inch. Keep in mind that diameter, 3/8, 4 holes, so all 4 of these holes have a 3/8 dimension. This chamfer here, this little notch is 1/2 by 45 degree angle, so it's a 45 degree angle, 1/2 inch both ways. And it's typical, so that means this other side is identical to that side. But this one here is basically depicting that it's written in fractions of an inch. As we go on to our next print, up here on top, I'm trying to use examples in the book because that's what you have. We have a ton of examples that we can use. But I figure if I use examples in the book, it should go along with what's being read. So this is the same exact print that's on the other page, except now it's in decimal inches. It's all up to the designer or the engineer to use whatever he would like to dimension. It might be decimal inches, it might be fractions of an inch, however he wants to do it. So that's why when I told you when this class first started to memorize your decimal conversions to fractions of an inch. So this is still 0.375, 3/8 of an inch, 4 holes, same thing applies. Same thing here, so instead of having 1.5 as a fraction, they have 1.5. 0.5 is the decimal equivalent to 1/2 inch. So get those decimal to fraction equivalents memorized. You're going to be using them religiously in this class. Some of the prints might be fractions, some might be decimals, and the next example is actually metric. So as I move this up, so this bottom one here, it's a metric. It all depends on what product you're building and what company you're working for. A lot of our companies in our area, they use metric because some of their products coming in are out of the United States, so they use a metric. So same thing here. So basically what do they have? 10 millimeter hole, 20 millimeters, 37 millimeters. How do I know it's in millimeters? It's usually down your title block, and I'll get to that. Yeah, we'll get to that later on. But metric, decimal inches, fractional inches. You might see, it depends on what company that you're working for, you might see all 3, or they might just stick to the decimal. Most of them stick to that decimal equivalent. That's why decimals, when you have your decimal equivalent to fractions memorized, it makes it a lot easier on the shop floor. The next couple pages we start getting into a lot of the print formatting. This example here on the top is actually an example where they use both. And the very next page, as you can see, they have decimal inches and they have metric right underneath. So that's what they call a dual dimensioning system. When they use the dual dimensioning system, they're going to tell you what is on top. That's what the bottom of the page is telling you. For example, inches on top. So when you see this in the title block, inch on top, millimeter on the bottom. So 1.233 inches or 31.318 millimeters. Here it's just the opposite. It's flipped. The millimeters are on top, inches are on bottom. Here they got the dimensions are in the brackets are millimeters. So a 1.233 is decimal inches. Here is our millimeters, 31.318. It all depends on who's designing that print. They're not all going to be the same. So get used to using different types of dimensioning styles. Now, as we move on to page 101, you're going to see this bottom down here. The bottom, I'm going to zoom in here a little bit. Like I said, grin and bear me for a second. Here's where this is basically a full print. As you can see, we have our object. It's centered in the print. Upper right hand corner, we have our revisions. Lower right hand corner down here is our title block. Typically, most designers, they follow this format, but a lot of the times they don't. Typically, your title block is always going to be in the lower right hand corner. Now, what does all this stuff mean, right? Revisions. Right here. It is saying revisions are something that they've changed on the print. So, for example, this is A. A was 1/4 inch diameter. So as you look right here, A, they changed the diameter of the hole to 0.265. So they made that revision. It's documented on that print. It is usually dated and approved. So revision is something, as they were making the product, it didn't work. They needed a different dimension. So they put a revision in there for whatever application they had to do. So revisions are just changes that they made on the print. So right here, A, that used to be 1/4 inch. Obviously the hole that they had there previously was not big enough, so they increased the size to 0.265. 1/4 inch is 0.25, so. Alright, what else do we have on this print? Let's start over here. Revisions is done. Right here we have a front and right side view. Keep in your mind we don't have a top, bottom, so we just have two views. They figured that's the only types of views that we needed for everything on that print. So, notes. Notes are basically just any additional information that you need. So, right here it says remove all burrs. So when you're done, remove all sharp burrs on that product. Machine surface to 1/8 of an inch except noticed. And it says cadmium plate unmachined surfaces. So these are notes that you might need or may not need when you're fabricating this part. Typically your notes are just, like I said, they're just additional information for you to finish that product. Now, title block down here. This is a big one. Understanding this title block means a lot. So, let's just start. We'll start left to right. So, this tells me right here, next assembly. Next thing right here, heat treatment. Now, title blocks may change, like I said, who's designing it. So, heat treatment is going to be normalized before machining. So, they're going to soften that material, make it easier to machine. They might have a hardening process after it's machined. But this title block is going to tell everything you need to know about that object. Material. This is steel AISI 1020. So it's telling you material. As you get right here, it's going to tell our tolerances. kind of hard to see on here. Your tolerances, is to explain a tolerance, it could be a plus or a minus or just a plus. So for example, if I had a dimension that was 1/4 inch plus or minus a 1/16. So 1/4 inch, you add a 1/16, so that's 5/16. Subtract a 1/16, so that product could actually be 3/16 to 5/16 actual size. So plus, you go up, minus, you go down. Some of them are only one way. It might be just a minus a 1/16. So the range of that product, if it's just a minus a 1/16, would be 3/16 to 1/4. Or if it was just a plus, just the opposite, it could be from 1/4 to 5/16. But it gives you a range where that product can fall within. This is very rare when you fabricate something that it's going to be exact. Because we have heat going in there, expanding, contracting, distortion. So they give you a tolerance that it can be in. So that's your tolerance. So as you go into your title block, very hard to see here. I'm going to go over here and take a little look. Okay, it says plus or minus a 64 for your fractions. Decimals, looks like it's up to 10 thousandths of an inch. Angles are, let's take a look over here quick. My eyes are getting bad, I'm getting old. It's 1 plus or minus 1 degree. So, anything that's in fractions, there is plus or minus a 64. Decimals, up to 10 thousandths of an inch. Remember, tenths, hundredths, thousandths. Angles are plus or minus 1. So that's a tolerance. It's a range that it can fall within and be acceptable. What else do we have on this title block? It's a third angle projection. You should know that from chapter 4. The date, who made it, who's checked, and who approved it. Also, what else do we have on this title block? Probably the company. What the product is. This is a spacer. And it also tells you right underneath there 2 required. So we actually got to make 2 of these. Release number, drawing number is critical because a lot of times you get into these prints, there might be 35 pages to that. It says sheet 3 of 7, full size, so the scale is full size. So this is the actual size of that object. 4 inches overall length, plus or minus 5 thousandths. Now this right here, when you see this on a print, this does not, they call this the general tolerance. So anything that you see on here follows that general tolerance. And if you look at this 4, it has a minus 5 thousandths of an inch. That is a direct tolerance. So that tolerance is only applied to that dimension. Anything else on here that does not have that, you follow these general dimensions. Same here. We have 1.015 plus 5 thousandths. That dimension only, that tolerance only applies to that dimension. Alright, scale. We'll talk about scale for a little bit. What is scale? This would be a 1-to-1 scale because it's actual size on the paper. Or 1-to-2 or 2-to-1. So when you get into scale, that does not change the dimensions on the print. Every dimension on the print is true. When you get into scale, it models it down. For example, if this was a 2-to-1 scale, 2 inches on this paper would represent 1 inch in real life, or 10-to-1. Because a lot of times you get into these bigger products, they're huge, they're not going to be able to fit them on a sheet of paper, so they scale them down. And it could be the opposite, where they got something really small, they scale it up so you can see it. So that's what scale is. Don't get too wrapped around the scale. You follow the dimensions, because I've had students in the past, they'll say, well, it's a 2-to-1. 2 inches on here equal 1, so they start multiplying everything by 2. No, the dimensions on the print are true. Scale has nothing to do with the dimensions. The scale just is telling you that the size of the object related to what it is in real life. So don't get wrapped around the scale too much. So drawing number is really critical too. Make sure your product matches your drawing number. Because when, like I said, you start getting into multiple sheets, there might be different views of that, and they'll go back to that drawing. This is drawing number, sheet number 4. Same drawing number, just a different sheet. So kind of go through here, go through the book, follow this formatting. This is typically a very basic print. Your title block is going to give you a ton of information. Make sure you follow it. The main thing that I would probably focus on is the title of it. This is spacer, how many are required. Make sure you follow your drawing numbers. These tolerances right here are really important. These are your general tolerances that apply. Unless there is what they call a specific tolerance given to that direct dimension. So for example, plus or minus a 64th, this is 2 inches. So this could actually be 1 and 63 64ths or 2 and 1 64ths. It can fall within that range. So follow these tolerances, understand them. If you have questions, I cannot stress that enough, to contact your instructor. As we continue into our print formatting, as you're going through, this is what they call a routing sheet. Right here. This is a very basic example of a routing sheet. Now, you notice there's no print. There's no object. A routing sheet is designed to give you a step-by-step procedure of putting that product together. So the very first step right here, pull stock. So you're going to go up on the shelf, grab this 60 inch by 120 inch 11 gauge, blah blah blah, and then you're going to shear it to a specific size. Every step of that routing sheet has to be completed. So a routing sheet is basically a step-by-step procedure to walk you through putting that product together. Some companies also get into detail where you might take part A, tack to part B, take part C, tack it to part B, and it's going to tell you a step-by-step procedure of how to put that product together. That's what a routing sheet is. I call them routing sheets. So what else you might see in a print? Is what they call zoning. As you can see up here in the top left-hand page of your book, here's an example of zoning. Any of you that have looked at a plat book, it's identical to a plat book. So on the print, they'll say, go to B2 to find this dimension. So on some prints, they'll have letters or numbers going either way, it does not matter. So we go to B, we find 2, we come out, we meet right here. So here's zone B2, you should find that dimension in there. Your final exam is going to have examples, and you're going to have examples in your test. It's going to say go to zone 1A, or it might be 1C to find this dimension. So that's what that is all about. That's what zoning is. So as you can see in this chapter, we're going through a lot of the formatting, the print, the title block, zoning, heat treatment, things like that. Don't get too alarmed. Everything is going to be given to you. You just have to find it. You just have to know where to look on the print. Also in this chapter, they're going through some different ways of how things are dimensioned. Now, this depends on your company. Strictly on your company. Some use old prints, some use new prints. For example, old practice, you used to have diameter 1.25 and they'd write DIA for diameter. Current practice right now is this the diameter symbol right here, boom. So this right here gets more into machining. That's something that you would have to probably concentrate on. But these are just current practice, old practice. You're going to probably see a little bit of both. So go through that. So this chapter we hit on a lot. Go through the book, follow this little lecture, go read through it, go through the examples in the book. Hopefully this helps clear up a lot of the print formatting. So as we go back, you understand the title block. It's going to contain a lot of information that you need. The type of material, your general tolerances are very important. Things like that. And at any point in time, make sure if you're confused, you contact your instructor. Now we're done with chapters 4 through 7. You're going to have a test. When you're ready to take that test, make sure you contact your instructor. It'll be a written test. It's not going to be online. Because of all the prints that you're going to be looking at, it's going to be hard to get them in on an online format. I find it simpler for students to just do paper and pencil. It seems to work a lot better. You got the print right in front of you. You got the question. You can look up the answer, whatever you need. So, but if you have any questions, make sure you contact your instructor. And keep in mind, we're always going to have a little lecture time set aside. We'll have it hanging out in the hallway or in the welding lab. Okay. For example, it might be from 1 to 2 on Tuesday afternoon. We'll do a print reading lecture on whatever needs to happen. So take advantage of it. Our main goal here at Nicolet College is to make you successful. And that's what we want to do. So we can't help you unless we know that you need help. So, all right.